Hi, students. This is Mr. Werman here. So today we're going to talk a little bit about linear expressions. We're going to be adding linear expressions with positive and negative constants and coefficients. I'll show you a couple examples with algebra tiles, and then I'll have you all try some in your notebook. Then you'll be able to do the work independently, the skill practice worksheet. All right, so that's kind of our plan here today. So first off, what is linear expressions? Well, this is in page 396 in your textbook. So linear expressions, these are basically algebra expressions where we have a variable, and for our variable, it's raised to the first power, so it's not x squared. It's x is not divided by something, but we just have something like, for example, 5x, 3x plus 1. Things like this are all examples of linear expressions. Okay. If we know, remember, if there is no number in front of the variable, for example, we know that number, that constant, this coefficient is really a 1 when it's not there. But all those are examples of linear expressions. Notice there's no equal sign. We're not doing equations right now, just expressions. Okay. We'll do a lot of simplifying those by combining like terms. And that's what we'll get to here. All right, so let's look at a couple examples. First, we'll use some algebra tiles to represent this. It helps us to visualize this process, and it makes it a little bit easier when we are adding those linear expressions. Okay, so let's start off with this one where we have 3x plus 2 as one linear expression, and to that we're going to add a x plus 1. Okay. So we'll show this here with our algebra tiles first of all. So we have three x's, right? If you remember from any lesson on algebra tiles, these long ones represent the variable x, right? They're unknown. So since it says 3x, we have three x's. And plus 2, these represent the number 1. So 2 of them would represent the number 2, right? And x, as we said already, if there's no coefficient for that x, it means 1. So we have 1x and 1. All right. So simple enough. If we were to add this linear expression, we see we have 3x plus 2 plus x plus 1. We really are just combining our like terms. In this case, we seem to have now 4x's, right? And we have 3 1's. So we added this 3x plus the x to be 4x's, 2 plus 1 being 3. Simple enough, right? Can we go any further? Can this actually equal 7x? No. You see why it cannot, right? This is 4x's plus 3. Totally different than 7x. 7x's would be seven of these tiles, right? So this is just 4x plus 3. All right. Let's look at another example real quick. So let's look at, for example, we have the expression 2x minus 1. And to that we will add a negative x plus 4. Okay. So if you remember with our algebra tiles as well, right? The colored side is our positive, but on the back of everyone, it is red, which represents a negative, right? Or minus, the same thing. So we have two positive x's there. We have a negative x there. This minus 1 can be represented by a negative 1 there. Okay. And our positive 4 can be represented by 4 positive 1's. Okay. So again, this is 2x minus 1 and negative x plus 4. So if we were to add these linear expressions, we're really just combining like terms once again. So let's just kind of put the like terms together for a second. Right? So now we see when you first add these, you might say, okay, now I have 3 x's and 5 1's, right? There are 3 x's, there are 5 1's, but we see that some are positive and some are negative. So we have our 2 x's and our negative 1 x and our 4 1's and a negative 1 there. Okay, so these kind of cancel each other out, right? We call those zero pairs, right? What is 1x minus 1x? 0 x's, right? So if we have a positive x and a negative x, these would cancel each other out. Okay. And same thing here. If we have a positive 1 and a negative 1, these are also 0 pairs, right? What is a 1 minus 1? 0, right? So these would cancel each other out. What we'll be left with? X plus 3, right? If I had to show this one algebraically as well, right? If we got 2x minus x, right? And a negative 1 plus 4, again, we have an x, or 1x, right? And a negative 1 plus 4, or 4 minus 1, is 3. So we have x plus 3. Simple enough. All right. Okay, now let's try this more. Hopefully that makes sense visually. Now let's try this also just kind of the straight up algebraic method. We're just using writing. Right. All right. So let's try this. So I want you all to write this in your notes. We'll try a couple examples here together. And hopefully, if you're still a little lost, that's okay. This is new stuff. Seems weird. Don't worry about it. We'll get there. The important point is we keep trying, we stay focused, and we'll get there, all right? So let's try another one here. We have a 5x plus 1 and a 2x plus 2, right? If I were to show you with algebra tiles, we'd have 5 of those green, 2 of those green there, 1 yellow, 2 yellow, right? Again, we're just combining our like terms. So we have, I'm going to underline our like terms here. We have those x's again, right? So we have 5x's there, 2x's there. If we add those together, right, 5x plus 2x ends up being a 7x. Okay. We have our 1 plus the 2, simple enough. That ends up to be 3. Right? Again, can we simplify it any further? Can you make that a 10x? No, we cannot, right? These are different terms, so we cannot combine those terms. All right, 7x plus 3, that's it. That's simplified. We'll never know what x is, and that's okay, because we're there. That's all we needed to do. All right? Okay. Let's go through one more example here together, and then I could go through some more if anyone needs them. All right, so let's see here. We have 2x minus 1 plus and negative x plus 4. Okay. Okay, again, we have negatives involved in this. The tricky thing is we kind of move our numbers around. Just remember that minus or negative sign, right? It needs to stay with whatever it's attached to, right? Okay, so 2x minus 1 and a negative x plus 4. And again, minus and negative are the same thing. So like before, let's combine our like terms, start with our x's. So in other words, we have a 2x minus x, and we have a minus 1 and a plus 4. Okay, again, the minus 1, negative 1, minus x, negative x. That's the only part you might be tripping up on at first, okay? So make sure you keep those straight. So if we combine those together, 2x minus x is not 2, right? Because remember, this means we're like an invisible 1 right there, right? It's really a negative 1x. So what is 2 x's and you take away one of those x's? Or if you have 2 positive x's and 1 negative x, we have a 0 pair there where it's 2 of our x's and you take away one of those x. You'd be left with just 1x or x, right? Meaning the same thing. Okay. And here we have a negative 1 plus 4 or a minus 1 plus 4. Same thing, right? 4, if you start at negative 1, add 4 to it, we're going to end up with a positive 3. Okay, so what is this linear expression? We would say just x plus 3. Okay, hopefully it's making a little more sense. If you're feeling like you totally got it, great. You could be ready to do it. If not, I'll show a couple more examples for you to watch here on your own. So if you feel like you got it, you're good. If you want a couple more examples, we'll go over those now. Okay, let's try a couple more with both positive and negative. All right, start with the positive one. Let's go something like 3x plus 7 plus, let's say 5x plus 4. Okay. So, great. So again, you should be writing these down in your notes if you're still struggling a bit here. Just combining our like terms. We got 3 x's here, 5 x's there, 8 x's. 3 plus 5 being 8. And then if we look at our other term here, 7 and 4, combine those like terms, just being 11. 7 plus 4 is 11. Boom, we're done. We can't go any further. This is a term, this is a term. They cannot be combined. They are not like. All right, maybe one more here. Okay. All right, let's see. Let's try something like a 3x minus 7 plus, we'll say, again, let's go with a negative x. We'll make this one minus 2. How about that? Okay. 3x minus 7 plus negative x minus 2. All right. Again, combining our like terms. Remember that negative x. There's that invisible 1 right there. Okay. So it's really like a negative 1x. So if we have 3 x's, you take away one of those x's. Or if you have 3 x's and you add one negative x, when those x's cancel out, we're left with a positive 2x, right? So I could just write it like this real quick with our like terms near each other. Okay. So this becomes our 2x. Okay. And then a negative 7 minus 2. Negative 7 minus 2. Right, both negatives. So you're 7 to the left of 0. You go back 2 more spaces. You're now 9 away, right? So now we have a 2x minus 9. Okay, again, totally simplified. That's as far as we can go. Nothing more we can do. This is a term. This is a term. They are not like terms. We cannot combine them. All right. Okay, hopefully that was helpful. So yeah, as you watch these, if it's going a little fast, feel free to pause it if you're watching this on your own. Or if it's posted, you can go back and check it again or watch it at home later if you need that extra assistance with this. All right. Let me know if you have questions. Thanks so much. Have a great day.